Chapter 3, Lesson 2, Rational Numbers. This is a super important lesson. You're going to see a lot of new vocabulary words. You're going to want to get those down and make sure you understand what they mean, how to use them, and how to identify them. Let's get into it. First, we're going to talk about the real numbers. Now, this is a whole system of numbers, so we want to make sure you understand all the pieces. What are the real numbers? It's a set of numbers that contain rational numbers and irrational numbers. Now, those are going to come up a lot, and you're going to have to know what those mean. Let's talk about irrational numbers first. Irrational numbers are decimals that never terminate. You know what that means? To never terminate? They never, like if you had a job, you'd never get fired. You get never terminated, okay? So it's a decimal that never terminates, and that means it just keeps on going on and on and on. And has no repetition. Okay, so I have some examples of some irrational numbers here. All of these examples cannot be represented as fractions. That's key, okay? So take a look at this first one right here. It says negative 2.172737. See, there's a pattern. It's going to be 47, 57, 67, 77, 87, 97, 107, 117. It's never going to repeat. All right, there is a pattern, but the pattern does not repeat. Pi, you guys are familiar with this one. The first three are 3.14, and it keeps on going. And to this day, there is no repetition of pi. There are scientists, laboratory professors who are still working on it with supercomputers. There is no repetition. This is the square root of 8. You'll learn more about those this year. There is no fractional equivalent of the square root of 8. The square root of 3/4? Nope. Negative square root of 77? Nope. And negative 4 and square root of 5? No. So those are just examples of irrational numbers. Let's move down. What are rational numbers? Rational numbers, these are things that we can actually write as fractions. There are all kinds of fractions or numbers that can be written as a fraction. What's a fraction? Basically like this, a over b, where a and b are what? Integers. And you know what those mean? All the positives and negatives in 0. Next, decimals that terminate. Okay, so decimals that do terminate or have a repetition. Repetition, not reputation. All right, so here's some examples of rational numbers, and these are the ones that can be written as fractions. Can, okay? So negative 5 and 5/10 can be written as a fraction. I'm not going to do all these for you, but I wanted to show you. That would be negative 5 and 5/10. See, that's a fraction, so that is a rational number. And all of these other ones can be written as fractions. Look all the way down the line. Now, there's a couple way at the end I want to point out. We did have some square root numbers in the irrational spot, but this one, the square root of 4 is 2, because 2 times 2 is 4. So 4 has a root of 2. Remember the word for this sign? Square. So you'll get this lesson later on in chapter 4, I think. So that's a square, and that's a 2 by 2, and the area of this is 4. All right, so this little thing right here, you can barely see. It's a 3. That means the cube root of 8. Well, we know that a cube looks like this, 3 dimensions, like a dice or a box, and all dimensions are the same. So that's 2 by 2 by 2. And if you go 2 by 2 by 2, the volume of this is 8. So that can also be written as a fraction. You'll learn a lot more about that as we move along. All right, let's get looking at this. How do we organize these things? I'm going to make this bigger so we can all see, and then I'll zoom out as we get closer. I want to start in the very center. Well, actually, I want to start out here. We've been learning about the real number system. Okay, now the real number system, you notice I have a oval circling. I don't think ovals can circle, but you get the idea. So it's circling all of this stuff. So everything inside this perimeter are the real, all of these things inside here are real numbers. So rational numbers are real numbers, irrational numbers are real numbers. Okay, but what you can see also, how you read this thing, you can see that irrationals are outside of the rationals. So those aren't the same, but they are still both considered real numbers. All right, let's get to the very smallest one here. The smallest one is called natural, or also known as counting numbers. Those numbers go like this. They start at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All these dots mean they just keep on going. A million, a billion, a trillion, and they just keep on going and going and going. Where do they begin? They begin with the number 1. Where do they end? They do not. Notice that there are no decimals in between, like the 3 and the 4. They're just natural numbers. Now the next category is whole numbers. Now see how this bubble also has a natural counting bubble inside it. So whole numbers are all of the natural numbers, including the number 0. Okay, so what are the whole numbers? 0, 1, 2, 3, 4, and forever. All right, now going to the next bubble. Natural numbers counting was the first one, then whole numbers. Now we get to integers. And you guys learned about these just a few lessons ago. What are the integers? They are all the negatives. See this? Negative 1, negative 2, negative 3, and so on and so forth. And they just keep on going. They are also including the 0 and the natural numbers. So integers are all the negatives, all the positives, excuse me, and 0. Let's go to the next bubble. Rational numbers. What are rational numbers? Rationals are natural, they are whole, they are integers, and now I have this area out here that has nothing in it. Well, all we have to do is figure out what rational numbers are. And right up here, we had noted, what are rational numbers? Rational numbers, they can be written as a fraction. Now, all of these numbers, like an integer, like -5, can be written as a fraction. You just put a 1 underneath it. You guys know that. Okay? All the natural numbers can be written as a fraction. You just put a 1 underneath it. 0 can be written as a fraction. You just put a 1 underneath it. All right? So those are all fractions. That's why they're rational numbers, because they can be written as a fraction. But what is a rational number and is not an integer, whole, or natural? Well, here's an easy one for you. 1/2. You see, 1/2 fits between where? 0 and 1. All right, what's another one? 5 and 3/4. Yep. -7 and 1/7. Yep. And you can see there's quite a few numbers that fit, that are rational. They can be written as fractions, but are not integers, are not whole numbers, are not natural counting numbers. So all of these up here, you can do decimals. You can do negative decimal. You can do repeating. We'll learn about those in a little bit. You can do negative repeating. All right. You can do, what else can you do? Super long ones like 521 and 1700ths. Yep, that's rational. So none of these that we've written in this bubble here fit as an integer, whole number, or natural number, but they are still rational. Since you're not in the classroom, I want to say one more thing I would not have said, or I would have said if you're in the classroom. Imagine having a ruler. I'll make a short ruler here. And on this ruler, you have your little marks. So we'll call this the 1-inch mark, and we'll call this the 2-inch mark. And this would be the 1/2 inch. This would be quarter, 3/4. And you got your little 8ths in here, and so on and so forth, 16ths, 32nds, all that stuff. Well, these two numbers are called real numbers. Okay, these two numbers are called rational numbers. I'll call it RAT for short. These two numbers that are circled are integers, they're positives. Those two numbers are whole numbers, and those two numbers are also natural numbers. Spelled it wrong. They have a lot of different things that they can be. Now, the things right between it from 1 to 2 in the middle are all, not all, but are mostly rational numbers. Like this mark right here, ½ inch, that's a rational number. Okay, because it's not 1, it's not 2, it's in between. Down here, 1/4, rational number. 3/4, rational number. 1/8, rational number. All right, so there's quite a few numbers. Actually, there's infinite amount of numbers between 1 and 2. All right, let's go down to the last bubble here. This is called irrational. Now, we talked about what rational numbers are. They're all those things. But what's irrational? We only have one bubble here. So what are they? Well, you just go right back up and you look at it. Pi. We'll put pi in here. Okay, never repeats. This keeps on going. What's another one? Let's go. Let's make up one. 2.010010001. I'm just adding more zeros in between the ones. That means it's never going to repeat. It is a pattern, but it's never going to repeat. It just keeps on going and going and going. So I'll put these dots. That's irrational. We can't write that as a fraction. Impossible. What's another way we can do this? Oh, the square roots of non-square numbers, like the square root of 5. Can't do that. All right, you could try. You can even put it in your calculator. There is a square root on your calculator. It's going to estimate it. Okay, it's only an estimation. All right, so those are some examples of irrational numbers. Can you have negative irrational numbers? You sure can. So the negative square root of 7. Yep, irrational. All right, let's go down to the your turns. Now, here's where you can just write along with me, or you can stop your video if you think you have an idea, and however you want to do it, whatever is best for your learning. So name all sets to which each value belongs. So we're talking about naming, all right? And here's all the names that we just talked about. So let's go down this first one. First one is -5 and 3,125 10,000s. Now, just as a refresher, you need to know your place values. Tenths, hundredths, thousandths, 10,000ths. Okay? So let's begin. Since this is a decimal and it stops, notice it stops right here. It doesn't keep on going and going and going. That means it is a decimal and it does not, excuse me, it does terminate right at the end of the 5. It terminates, it stops. Okay, and it does not repeat itself. So that is a rational number. But let's back up. What else is it? It's also a real number. For sure, it's a real number. It is also a rational number. I'll put rational. Is it anything else? Let's look. It's real, it's rational. Is it an integer? No, it's not, because it has the decimal numbers after it. Is it a whole number? Definitely not. Is it a natural number? Definitely not. Is it irrational? Well, if it's rational, it cannot be irrational. It can't be both. All right, so that's it. It's a real and rational number. Let's go for this one. You know these, the absolute value bars. What is the absolute value of -24? It is 24. Okay, well, what is 24? Let's look up here. Well, it's a real number, that's for sure. It's real. It's down in this bubble right here. 7, 8, 9, all the way up to 24. So it's a natural, it's whole, it's an integer, and it's rational. Okay, so it's real, it's an integer, because it's positive, regular number. It's a whole number, and it is a natural number. I'll put nat for natural. Okay, what's 0? Well, if you look right up here, 0 is right there. So it's in the whole numbers circle, but it is not inside the natural. All right, so we're going to call this a real, a rat, It is an integer, and it is a whole number. It's the first whole number. It is not a rational number. All right, going down to a repeating bar. Now this is our first repeating bar, but we have some information up here. Okay, it says that rational numbers, way back up in our notes, are decimals that terminate or have a repetition. All right, is there a repetition here to this repeating bar? Yes. What does that repeating bar mean? It means that this number is going to repeat itself forever. Okay, now there's a pattern there, and it is repeatable. Okay, so that's why we use this bar. This bar means it's over the 1, the 2, and the 3. That means all three numbers repeat over and over and over. So you haven't learned it yet, but repeating bars are rational numbers. Now we have a negative out in the front. Doesn't mean it's an integer because it is a decimal. So what is this? It's a real number. It's a rational number. And that's where it stops. It's right out here in this circle. Okay. Moving on, we need to simplify this before we can deal with it. Okay, so this is a negative 24/6. All right, what's 24 divided by 6? 24, I'm just working on this right now. I'm not using the negative sign. 24 divided by 6 is 4. I bring down the negative sign and simplified, it's negative 4. So let's name it. It's real, it's rational, it is an integer, it is not a whole number, it is not a natural number. So it was just three things. And finally, 2 3/8. Well, that looks like a fraction to me, doesn't it? So it is real, and it's rational, and that's it. All right, let's go see what else we can find. All right, here's some more your turns. Circle all values that are rational numbers. Is 18? Yep. What kind? Well, it's a bunch of names, but it's a whole number. It's an integer. It's a rational number. It's a real number. The negative square root of 75. Is 75 a perfect square? You know, hopefully some of you guys have had that lesson. I don't think that all of you have, and that's okay. What are square numbers again? Well, let's count. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So these right here are perfect square numbers, and there's a pattern. 1, 4, 9. The next one is 4 times 4, which is 16, and 25, 36. And 36 is 6 times 6, so 7 times 7 is 49. 64, 81, 100, and it just keeps on going. Okay? Is 75 there? 75 is between 64 and 81, so no, it is not rational. This is, because it's a fraction, that's an easy one. This is a fraction, and it can be simplified to 5 as well as a whole number. So that is definitely rational. Square root of 6 is right between 4 and 9, so that's irrational. The cube root of 64. Well, what are our cube numbers? I'll give you some. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Do you hear the word there? Cube. Cubes have 3 dimensions. It's 3 numbers. So 4 times 4 times 4 is 64. So yes, that can be simplified to 4. And this one is repeating, and we learned that repeating are rational numbers. Yep. Okay, this next one gives you some directions. Answer it always, sometimes, or never for the following ones. Natural numbers are what? Integers. Are they always integers? Are they sometimes integers? Or are they never integers? Well, natural numbers, if you look back at the circle thing we did, natural numbers are inside the integers. So natural numbers are always integers. Irrational numbers are what? Rational numbers. Are they always, are irrational numbers always rational numbers? Are they sometimes, or are they never? Well, remember, but our circles, those circles did not intersect. They were separate from each other. So that is a never. And then rational numbers are always, sometimes, or never real numbers. Well, remember, rational numbers from the bubble is inside the real number bubble. So rational numbers are always real numbers. All right, now we really get into the fun, the meat of the subject. All right, so I've told you that repeating numbers are rational. Okay, but now we're going to learn how to prove them. And you, as a student, have to be able to do this during this lesson. Now, it's going to take some super concentration on your part, and I wish you were in the classroom to ask questions. And as you go over this, you may want to pause and rewatch this portion a few times and try to master it. When we're in class together this week, please ask if you're confused on this one, and we'll talk about it in class. So here we go. This is your example, okay? We're turning a repeating number into a fraction. And there's a long process to do this for proof, okay? So let's begin at the very top. First of all, we say that n is now going to be equal to 5/10 repeating. We've declared it, all right? We are saying it is so. N is exactly equal to 5/10 repeating. 5/10 repeating is exactly equal to n. That means that these two numbers, the variable n and the number 5/10 repeating, are exactly the same number. All right, now that we have established that, let's write it out in long form. N is equal to 0.5555, and you can put as many fives as you like. I don't need to have that many. I put a ... to signify that the fives continue on forever. It's just another way to write the one up here. Now, I would like to move this decimal, okay? I'd like to move this decimal one time. Why did I choose one? Because up at the top, I can move it here to here. And to do that, I need to multiply it by 10. All right? So the property of equality, that's a new property, I believe, for you. The property of equality means if I do something to one side, I do it to the other. Let me write that out. The property of equality. Okay, so since I want to move this decimal point once over here, I'm going to multiply this side by 10, and that's what does it. All right, so you can see I put parentheses around this big long number, and then I put 10 on the outside, and that signifies I'm multiplying that side by 10. Well, the property of equality says if I do it to one side, I better be doing it to the other side. So since I multiplied the right side by 10, I need to multiply the left side by 10. Here's 10. I put parentheses around the end to signify multiplication. Now, that's pretty equal, isn't it? Why am I keeping it equal? Why am I using the property of equality? Because it's telling me to. It's telling me, hey, these pieces are equal. So if you do 10 to one side, you better do 10 to the other to keep it equal. All right, let's do this operation. 10 times n is 10n. That still means to multiply. A number against a variable with no operation sign between it means to multiply. And 10 times 0.555 is now 5.555. And you can see by multiplying 10 times it, it moved the decimal point one time. And that's what we were trying to do. All right, you'll find out in a little bit. All right, so now we have this line here. It's looking good. All right, now what we want to do is we want to take this line, okay, that line right there, and we want to move it down to here. All right, we're doing another property of equality. We took this line at the top and we moved it down here. And I'm going to draw this line here to make it more interesting for you. And we are subtracting. See this top line that I just circled up here? This is n equals 0.5555. I brought it down here, and I'm now subtracting it from the top. Subtracting. Okay, see the subtraction sign? This is 10n minus n. Well, if I have 10 n's and I take away one n, what do I have? I have 9 n's. Well, if I'm subtracting n from this side, I better be subtracting the same amount, property of equality, from this side. And remember, up here and up here, I said that they are exactly the same number, n and 5/10 repeating. All right, so over here, we're going to do some subtraction. Now, wait, see these dots down here? Way down here? They're 5 over 5. So we all know that 5 minus 5 is 0, and these are all 0, 0, 0, 0, 0. And we go to here, 5 minus 5 is 0. 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 Bring down the decimal point when you're subtracting, and 5 minus nothing is 5. All right? That's the reason why we multiplied it by 10 and then subtract it by itself, is to get rid of that repetition. Now here we go. 9n is now equal to 5. All right, well, how do we get rid of the 9? Well, we have to use another property. Okay, so to get rid of the 9, we want to divide it by 9. Because 9 divided by 9 is 1. And 1 times n is n. We'll talk about that in a little bit. So if I divide one side by 9, what do we do? Property of equality, divide the other side by 9 as well. All right, so let me blow this up for you. Okay, 9n divided by 9. All right, what do we do here? Well, this is 9 times n over 9. Well, what's 9 divided by 9? It is 1. And what's 1 times n? N. There's another property. Identity property of multiplication. We used it right here. We wanted to know the identity. So we divided both sides by 9, and we got it. All right, so we came all the way down here, and the answer is n is equal to 5/9. Well, what's n? N is also equal to 5/10 repeating, and n is also equal to 5/9 repeating. Therefore, 5/10 repeating is equal to 5/9. Now, if you don't believe it, check it on your calculator. Turn on your calculator and do 5 divided by 9. And when I do that on my calculator here, I'm getting on my calculator, let me put it right in between here, I'm getting this 0.555555. I think on my screen I have 7 5s. I have 7 5s here, and then all of a sudden I have a 6. Well, why is there a 6? It's because my calculator is not as smart as you guys. It has to round, okay? But we know that with the calculator, when they round, we know that it's not actually the answer. It's just estimating. Wow, that was a big one. Now we're going to do it all over again with the repeating of 9. Okay? But before we do, let's see what you guys think. Do you think that 9/10 repeating is as close to 1 you can get? Does that make sense? Do you think the 9/10 repeating is as close to 1 you can get? Or do you think it is 1? Let me make this better here. I'll erase this. Try it again. Do you think 9/10 repeating is closest to 1? The closest number you can get to 1? Or do you think it is the number 1? You have to make a decision right now. Is it the closest to 1 you can ever get, or is it the number one? Hopefully that makes sense on the video. Okay, you make a decision, you make a bet with yourself. All right. I, going to college and everything, I was always like, oh, it's the closest to one because it's not quite one, but it's super close, like 0.999999999. And the more I say nines, the closer I'm getting to one, but I'll never actually make it there. That's one idea. And then others in school thought, well, I think it is one. Like it's the same as one. So make up your mind right now what you might think it would be. And we're going to go on to it right now. So what do we do over here? Well, we start this whole thing. We declare that n is 0.9 repeating. And then we write it in a new way. N is 0.999. And I'm only going to do 3 nines. I don't want to do as many. And now, because it's only, the decimal point is only one away from being behind this repeating bar right here, because I want it to be there, I'm going to move it over once. To do that, I multiply by 10. So 10 times 0.999. If I do it to one side, I do it to the other because the property of equality. So 10 times one side, I better 10 times the other side. So now I'll perform this. 10 times 0.999 on my calculator, or in my head, is 9.99 repeating. And on the left side, 10 times n is 10n. Now, the key is I want to get rid of all of this repeating stuff right here that just keeps on going on and on and on. So I'll take this line and bring it down right underneath it. So that's 0.999, and that's also n. And I want to subtract it from both sides because I'm using the property of equality. So I want to subtract the same amount from each side to keep everything equal. So on this right side, all of these nines would match up, match up, match up, match up. And they would all be zeros until I get to here. 9 minus 9 is 0. 9 minus 9 is 0. Decimal point, bring it down. And 9 minus 0 is 9. On the left side, 10n, take away n. Well, if I have 10 n's and I take away one n, remember, hopefully you guys are thinking properties in your head. 1 times n is n. That's the identity property of multiplication. So 10n, take away 1n, leaves you with 9 n's. All right, so to get rid of this 9, I would divide this side by 9 to make just this n by itself. Remember how we did that over here? All right. So since I divided this side by n, I better do it to this side. And 9 divided by 9 is what? 1. So we just proved with mathematics, algebra, that 0.9 is exactly equal to 1. Now some of you guys are going to be like, whoa, I still don't believe it. But we use math to prove it. Look it over. It's true. I was blown away as you might be. All right, let's go on to this next one. Now we see a double digit thing. All right, so we're going to declare that this is n is equal to 0.23 repeating. We'll write it in a new way. N is equal to 0.23. Oops, I don't want the decimal point there. That is a mistake. 0.232323. Okay. Now the goal is we need to get rid of this repeating stuff. So I need to get the decimal point over 2 places. So instead of multiplying by 10, I multiply by 100. So 100 times 0.2323. And if I do it to one side, I do it to the other side. 100 times n. Now I perform the math. 100 times n is 100n. And 100 times 0.232323 is now 23.2323. Now I want to get rid of this repeating 0.232323, so I use this line and move it down. See how lovely it matches to create a whole bunch of zeros? All right, and I bring down this side, which was n. So n equals 0.23. This is what this line says right here. All right, and I'll subtract property of equality. If I subtract it from one side, I subtract it from the other. And so all this side is going to be zeros, and what's going to come down? 23. And 100 n's, take away one n, is now 99 n's. I'll divide the left side by 99 because I just want to know what one n is worth. If I do it to one side, I just do it to the other. And on my calculator, I have 23 divided by 99. And so n equals 23 99. Open up your calculator just to check, and you type in 23 divided by 99, and you should get on your calculator screen 0.232323, and there it is, proof. All right, so you saw that all repeating numbers can be written as fractions, and we proved that. That's going to take some practice for you to be able to do. So on your tests, on your homework, you got to show this process here. All right, now let's go down to this one. This is kind of just a refresher. This is converting fractions, decimals, and percents backwards and forwards. This is done in, I think, it's beginning as 4th grade, and you work on it all the way through 6th grade. So you should be masters at this. Some of you are not. Some of you have been taught a little bit kind of an odd way to think about it that gets you the right answers, but may not be totally true. I should say you're getting the right answers, but the thought process through might not be all mathematical. So let's begin. I'm giving you 9/16, and this right here, I have this word right here. This fraction bar means to divide. That's what it means. That's 9 divided by 16. So I'll just put in my calculator, 9 divided by 16 is 0.5625. And then I want to, gives a little directions here. This is from a book, this is not my stuff. Divide the numerator by the denominator, and we did 9 divided by 16. Get this. Now the book says move the decimal to the right 2 places. I don't like that. I know that's the way you learned it too. I don't, in math, we don't just want to move things because we're told to move things. We want to actually know why we're doing it. So if we want a percent, we know that percent is out of 100. Percent's out of 100. Okay, that's why we call it 100%. That is a full amount. All right, so if we want to know what the percent is from fraction, we don't just move the decimal, we multiply it. That's my multiplication dot. We multiply it by 100. So 0.5625 times 100, that is what is moving the decimal 2 places. So it's 56 and 25 hundredths. So it's not that we just move, we multiply it by 100 and it moves it over 2 times. So many students don't even realize that. Why by 100? Because percent is out of 100. All right, let's go backwards now. We begin with 84%. Well, if we multiplied to go from decimal to percent, we ought to divide, right? So we're going to divide by 100%. Well, what's 84 divided by 100%? 0.84. And to do this, all you have to do is read it, write it, and reduce it. So 84 hundredths. Remember, this is the tenths, this is the hundredths, 84 hundredths. You just said it. Oops, let me move it over. 84 hundredths. Now those are both even numbers, so we know that we can divide both. I happen to know that I can divide both by 4. So that will keep them equivalent. 84 divided by 4 is 21, and 100 divided by 4 is 25. So we always leave things in a reduced form, always. Okay, if you leave it like this on a test or a quiz or in your homework, even on your answers to your assignments on the Google Forms, you'll be marked wrong. So always make sure you reduce, simplify all you can. All right, this says repeaters. What does this say down here? Decimals with a repeating digit can be written with a bar, we know that, to show the repetition. The denominator for these fractions is always 9 or 9-ish. 9-ish. Okay, what do I mean by that? Well, look back up here. This is repeating. It had a denominator of 9. This one had a 9. This one had 99. So it's sort of 9-ish. Okay. All right, so now it's your turn getting down into this one. You can pause. This would be a good time for you to pause and practice these things. I'm going to keep moving on. All right, with my calculator, I'm going to make this thing easy. So to go from fractions to decimals, all I have to do is go 9 divided by 20. That's 9 divided by 20. And put my decimal point here, add some zeros, and go for it. But I tell you what, I do not like long division. So I'll just go 9 divided by 20 on my calculator is 0.45. And that as a decimal, I multiply it by 100 and I'll get 45%. Now since I have the decimal here, I'm going to work backwards. I'm going to divide this by 100%, and 5 divided by 100 is 0.05. I use my calculator to do that. And now I read this. This is 5 hundredths. I just heard it. I just spoke it. 5 hundredths. So I can't leave it like that and just reduce it. I know that 5 goes in there and 5 goes in here. So that is 1/20th. Now they're giving me a decimal. I can go backwards or forwards. I'll go backwards first. This as a fraction is 26 hundredths, because that's in the hundredths spot. And I know 2 goes into both. 13 fiftieths. Now to step over here in percent land, I'll multiply this by 100. I'm going to get 26%. Now they give me a fraction, so I just use calculator there because I don't want to do long division. So 11 divided by 28. I'll do that again just to make sure I'm getting it right. 11 divided by 28. I'm getting a long number here. It is 0.392857714. Okay, that as a percent. All right, multiply it by 100, and I'm going to get 39.2857714%. Next one, 38%. I divide by 100% because percent's out of 100, and I'm going to get 38 hundredths. I just said the fraction, 38 hundredths. I divide both by 2 because I can see that 38 is an even number. So that's going to be 19 fiftieths. Fractions to decimals now. Now this is giving me an odd one. Okay, there's a couple different ways to do this. You can convert this to a improper fraction. Remember how to do that? You go 9 times 1 plus the 1 would give you 10 ninths. Then you could divide that in your calculator, or you could just go over here. This is 1 and 1/9. So 1/9 as in your calculator, 1 divided by 9 is, hopefully you guessed it without using a calculator, 0.1 repeating. So use a repeating bar. All right, and then we go down here to the percent. So we're going to multiply this by 100, and that's going to be 111.1, and we don't have repeating percent, so we're going to round that there to that. And this next one right here, we have got to multiply by 100 to go this way. It's going to be 70%. Remember, it goes over 2 times. Common mistakes, some people say 7%. All right, and then going backwards, this is in the tenths place, so that's 7 tenths. And that's as reduced as you can get. All right, now you're going to get into your assignment. And we're going to do the odds together to make sure that you know what we can do here. I apologize for the long, long lesson. Maybe you're taking breaks. Write each number as a fraction. All right, so this one right here, we're going to write as a fraction. This is not a fraction right here. Not a fraction. Well, what is this called? It's called a mixed number. That's what it's called. Okay, so here we go. 3 4/5. Now, how do we do this? Well, we say that this is 5 times 3 is 15, and 15 plus 4 is 19 fifths. Okay, that now is a fraction. That's what they want you to do. Okay, there's other ways to do this. We can get into that, but I think that this is probably most likely the way that you're taught in elementary school. Let's go down to 15. How do you write 15 as a fraction? Pretty easy. Put it over 1. Number 5, how do you write negative 13 as a fraction? Pretty easy. Put it over 1. 7, how do you write 7 as a fraction? Easy again. I get all the easy ones. It's over 1. And this last one, this is a negative 2 3/4. So our answer will be negative 2 3/4. Now I'm not going to use the message where I multiply and then well, I'm doing this wrong. Let me back up. We're making it into, we're supposed to be making it into fractions. All right, so this is a mixed number. It's a negative, so it's negative answer. And multiply here and then add the top. So 4 times 2 is 8. 8 plus 3 is 11 fourths. So it's negative 11 fourths. Moving down, write each decimal as a fraction or mixed number in simplest form. So pay attention to that. All right, so this is 5 hundredths, 5 hundredths, and that can be reduced. And if 5 goes into both, that's going to be 1/20th. Number 13, this is 4 and, see the and there? 4 and 12 hundredths. Well, 4 and 12 hundredths can be reduced. I know 4 can go into both. It's going to be 4 and 3/25. This is going to be negative 3 and 24 hundredths. See the hundredths there? All right, and that's going to be negative 3. And what can go into 24 and 100? I know 4s can go into them. Okay, so 4 goes into 24 6 times, and 4's go into 100 25 times. Number 17, repeating one. So here it begins. You're going to need a lot of room, as you know. So I am going to write this into a fraction in simplest form. So where do we begin? Well, we look back at our notes if you need to. Get yourself some room. I have plenty of room here. You're not going to have enough room because maybe your 14 is in the way. But here I go. I'm going to declare that n is equal to negative 4 tenths repeating. And I'm going to write it in a new way. Negative okay? And then I want to move this decimal point right here past the repeating bar. So to do that, I'm going to multiply both sides by 10. Do it to one side, I also do it to the other. I perform the operation, 10 times n is 10n, and 10 times negative 0.4444 is negative 4.444. Now I use this line right up here. I bring it down, and I'm going to subtract it from here. Because the idea, remember, is to get rid of all these repeating numbers here. So when I do that, I subtract, all of those are gone, and what do I have left over? Just a negative 4. And 10n, or 10n take away n is 9n's. And to get rid of the 9, I divide by 9. If I do it to one side, I also do it to the other. And n is equal to negative 4/9. Now put that in your calculator, just check. 4 divided by 9, and your calculator is 0.44444. And remember, it was originally a negative, so it ought to still be a negative fraction at the end. And the last part, for your examples, identify all sets to which each number belongs. So what's 0? What are the sets again? Real numbers, rational, irrational, whole, integer, natural, all those words. So 0 falls inside, it is a real number. It is rational. It is an integer. And it is a whole number. It is not a natural number. So I'll skip over to 21. Notice what's happening here, the 25, 25, 25, it's repeating, so I could write this as 4.25, and all repeating things with repeating bars are rational, but let's back up. This is a real, it's rational, it's not an integer, it's not a whole number, it's not a rational number. So that's one that's done. And this one has a repeating bar, so it's real. It can be, or sorry, it's real because it's either rational or irrational, all those are real numbers. And it is rational because it can be written as a fraction, and we've learned how to do that. Wow, we're finally at the end. I apologize for such long notes, but there's a lot of details that you need to know. So you can cut this video, and I'll also include this video in this week's video, so that way you can go right to where you need to be and not have to go through the Edpuzzle again. So that's it. That's a wrap.